Akash Patel, and today's topic is recursion. Recursion is the technique of making a function call itself. This technique provides a way to break complicated problems down into simple problems which are easier to solve. The process in which function calls itself directly or indirectly is called a recursion, and the corresponding function is called as recursive. Certain problems can be solved quite easily. Example of such as problems are Tower of Hanoi (TOH), in order, pre-order, post-order, tree, traversals, DFS of graph, etc. Recursion may be a bit difficult to understand. The best way to figure how it works is to experiment with it. We can call a recursion function in two ways. First, direct recursion call, and second, indirect mutual recursion call. First, direct recursion call. If we call the same method from inside a method calling. Indirect and mutual recursion call. If we call a method from another method and another from another method and another method call from the first method, vice versa. How can we stop infinite conditions of recursion in Java? To stop the infinite condition, we must have the following: first, base condition, and second, recursion call. First, base condition. Specify inside if the condition where to stop the recursion function, proper recursion call. A recursive function is still recursive when recursive call is the last thing executed by the function. How memory is allocated to different function calls in recursion? When my function is called from main method, the memory is allocated to it on the stack. A recursive function calls itself. The memory for the called function is allocated on top of memory allocated to calling function, and different copy of local variables is created for each function call. When the base case is reached, the function returns its value to the function by whom it is called, and memory is deallocated and the process continues. Advantages and disadvantages of recursion. When a recursive call is made, new storage locations for variables are allocated on the stack. As each recursive call returns, the old variables and parameters are removed from the stack. Hence, recursion generally uses more memory and is generally slow. On the other hand, a recursive solution is much similar and takes less time to write, debug, and maintain. Thank you so much.